Hello, hello. Hopefully people can hear me. I don't know. Please let me know in the chat if my microphone's working and if the music's too loud compared to my voice. Also, let me know. New microphone, so the audio levels might be a bit fucked. All right, cool, perfect. Yeah, if the music's like imbalanced or whatever, just let me know. I'll edit that. But welcome to Git and GitHub 102, which is our part two of our intro to Git and GitHub workshop series that we do. I guess every year now. But essentially, if you haven't already gone to the previous event, this is essentially an event where we go over Git, what it is. You've probably heard of it every now and then. Oh, sorry about that. You've probably heard of it around the industry, maybe around your classes, whatever. And you might not know what it is or how to use it. It's not really taught in class, so we'll be going over that, and also going over GitHub, which is a very important big website. We did go over this previously in the last event, but we'll be kind of covering a recap of like everything that we covered in that event, and then a bunch of more advanced applications of all that stuff. So I'll throw the QR code on screen for a few seconds. It's at the top. It's on the bottom right too, like all the time. So if you do need to sign in like halfway through the event, the QR code won't disappear. So you're chilling. But it is there for a few seconds, and yeah. So this is the agenda we'll be going over for today. We'll be going over some recap stuff. So the first three concepts are mostly just recap of very, very short and brief of what Git, GitHub are, as well as some key concepts about Git itself, some of the commands that we covered last time. And then we'll move on to essentially a demo of more complicated features, I guess, of a few features of Git, and then a bunch of features for GitHub, because last time we kind of mainly just covered Git. This time we'll be hoping to cover a lot more GitHub stuff, but yeah. So this is from last time as well. If you don't know what Git is, it's basically a piece of software on most computers, and it's known as a distributed version control system that tracks changes in any set of computer files, usually for coordinating work amongst programmers. So again, if you've ever like worked on something collaboratively, this is essentially a tool that allows you to track who's doing what. If someone deletes a file, who deleted it, kind of in like Google Docs where you can look at the document history of the document you're working on. It's essentially like that, but instead of automated, you have to do everything yourself. And it's a lot more complicated than that. There's a lot more really complicated features, some of which I'm not going to cover today because they're very complicated. But again, we already covered this last time, so if you have not seen that, go ahead to our YouTube channel. I think it's youtube.com/Laurier Computing Society. But yeah, that's essentially a very, very overall brief thing. There's some bullet points for you. It's a version control system, and it's access to the command line most of the time. So it's a command line tool, but it also does have like a bunch of implementations in most IDEs and like things you'd program in and even online. So you don't actually have to use any commands if you don't want to. I highly recommend learning it with commands though. But yeah. And if you wanted to know like a little fun fact, it's an open source project started by Linus Torvalds. That name is kind of famous because he's also the guy who like the brains behind Linux essentially. So yeah, pretty famous guy in the tech scene. So GitHub is very different from Git. A lot of people use it interchangeably. But wow, that's a bit too loud. There we go. Basically, people use Git and GitHub interchangeably a lot of the time when they don't know what's happening, but they're very different things. So GitHub's a website, so obviously github.com, and it hosts people's repositories and code and projects and allows them to share with other people. Because you can use Git on your PC on your own, but you need a way to actually like share that stuff with other people and let them copy it and do all that stuff with it. So GitHub's one of the few implementations where like it's a website where you can push your code and you can like review with other people, etc., etc. It also has a bunch of other things. It used to just be for Git, but then they branched off into like a shit ton of other things. But they do a lot of software development. Like it's a software development platform, but they have a lot of project management tools now. It's like a very like you could run an entire company off of Git, or an entire tech company if you really want to off GitHub. So yeah, we'll be covering some of those tools today too as well. So yeah, some of the key concepts we covered last time for Git commands specifically is how to initialize a repo. So all these things I won't be covering again. I'll mention them as I'm doing them, but I won't explain how they work or whatever. Adding files to a repository, recording local changes, pushing local changes to a remote repository. So that would be a remote repository on GitHub in this example. You can also use Bitbucket or GitLab. and then pushing or pulling changes from those remote repositories or the origin, and then how to use working trees and branches. So that's everything we covered. We'll be using some of that today too, but not everything. So yeah. There's a few newer key concepts we'll learn about. One of them is actually just an addition to what we already know, which is adding files to a repository. So there's better ways to add files to a repository, more fine and granular ways of doing it. And also, we'll be talking about how to reset changes in a repository or like your local changes. So if you do add a bunch of code to a local repository, you could go ahead and delete that before you push anything and then re-clone it to your computer. But there's like better ways to manage that, because just deleting a repository and cloning it is not recommended, for a lot of reasons. But yeah, bunch of commands. I think two commands we'll be learning today. So yeah, as well as that, we'll be covering the project management side of GitHub. So the three big tools, or I guess products, we'll be covering from GitHub is GitHub Projects, GitHub Actions, and GitHub Wiki. And I'll be showing off examples of those too, like that we've used at LCS and Hawkx and stuff like that, or I have personally used as well. But projects is GitHub's implementation of a project management tool. It's an all-encompassing tool that lets you track issues like user or developer quotas, lets you track like who's doing what, backlogging stuff. It's really complicated if you really want it to be, but it can also be really simple. GitHub Actions is a way to automate workflows on your repository and automatically make code do stuff or deploy code to other places or whatever. For example, let's say you have like a website that you're hosting, and you push all your code to GitHub, but then you manually compile it and then like host it on a server somewhere. You can make a GitHub action that automatically, whenever you push to main, will compile that code and then deploy it to wherever it needs to be. So you don't actually have to do that yourself, which is really cool. There's a lot of automation stuff that can happen. We'll show off a really small example today as well. And then the very last tool, I guess, from GitHub that we'll be covering is GitHub Wiki, which allows you to make wiki pages for your GitHub repo. So let's say you have a really big project that a lot of people are looking at, and you want to teach them how to use it, whether that be through like teaching them how to use it from a customer perspective or a developer perspective. You can make a Wikipedia like encyclopedia thing that's very nicely rooted and nicely nested that kind of documents everything for you. So it's really cool. It's like a automated built-in like documentation system essentially if you want to like document your code. And that was a very brief overview of all three of those products. Will be basically the entire like workshop will be like next 40-30 minutes will just be showing off demos of how all of those things work. So yeah. So we'll be talking about, again, 2 advanced GitHub commands, quote-unquote advanced, not that advanced really, but they're really cool features that you should know. But the vast majority of this workshop is going to be centered around the project management tools that GitHub offers. So yeah, so let me just quickly switch over to Git. Okay, cool. So this is a repository that I have set up for 5 hours ago. As you can see, nothing on it. So we'll be doing the very basic stuff where we'll clone it, we'll add some files to it, very basic GitHub stuff. So first thing I'm going to do is copy the URL. I'm going to briefly cover this stuff. And let me know if this font size is too small. And I can make it bigger or smaller. So we're going to clone that repo. So again, that copies it to my local computer. And then we'll go into that folder. So there we go. And again, I'm using some very basic Unix commands as well that we covered last time. ls is list, like the list directory. Cd is change directory, and then git is obviously a git command. I think that's pretty obvious. Also my terminal will just tell me what branch I'm on, so it just says I'm on the main branch, which is kind of nice. You can see in here I only have 2 files, so we'll go ahead and quickly add some code to this using VS Code. So I'm gonna make a new folder called source. That's kind of a standard practice throughout the industry, and we'll just do like some math functions, really basic math functions. I couldn't really think of anything really creative this time around, so we'll be going over that. And we have these 3 functions that I'm gonna use. I'm gonna use GitHub Copilot, hopefully so that it can like auto-complete these for me. Thank you. So I don't have to actually like code this myself. I'm pretty lazy. There we go. Cool. So I went ahead and let GitHub Copilot complete these 3 functions for me. They're obviously wrong. I think dot product might be right for like a 2-dimensional vector. A cross product and wedge product are definitely wrong. But it doesn't really matter. The code specifically does not matter. That's not the point of this. So we're gonna go ahead and just push this to our local repository. Or sorry, a remote repository. So if I'm gonna show the like diff, I guess, or like the changes I made through VS Code. So as you can see right here, it tracked one change. It's this file, and I added all of these pieces of code to it. And as you can see, it's all green for now, which means I added all of this in one go. It's important to see that because we'll change that later, that functionality, and you'll see how it changes later. But for now, just note that it's all one big green blob, right? I'm gonna go back to the terminal now and just quickly do git status. There's a new change in there, so I'm gonna do git add dot, which adds all the new changes that are untracked currently, and then go back to git status. Oh, that's not how you spell git. And as you can see, there's a new file there called source/math.py, which is the file we just added. I'm going to commit that with a message of start work on math functions. And then I'm just going to sign that. Ignore this. This is just a new thing I set up on my side. It's very don't even worry about that. So just ignore that every time that comes up. But yeah, committed that and then push those changes to my remote repository. And now if we go to over here and then usually you'd have a prompt here that says refresh, but I guess I'll have to do it myself. There we go. As you can see, very basic stuff. We have this code here already know how to do this, not that complicated. So now let's think about a scenario where I've committed this code, it's been there for a while, whatever, and I work on it again. And now I want to change the functionality of these two functions. Let's say they're both wrong, right? Like really, really wrong. So I'm just gonna make them return -1 for now, and I don't know, 0 for this one, just to for whatever reason I just want to do this. But there's a situation where I don't want to. So the thing with git commits is that they should be very self-contained and small. Every new commit should be a specific thing, not a group of things. So if I'm working on a website, instead of making a commit that says update website, I should make 10 commits that says updated navbar with new icons and then updated footer with new copyright text. My commit should be very self-explanatory and small and not over-encompassing. So if I were to add these new changes, I could just do, in this case, obviously this is a really dumb example. This is really small changes. I could really just say update math.py or whatever, and it wouldn't be a big deal. But in the case that these functions are huge features of code, huge features of a product that I don't want to just bundle into one big change. What I can do and go ahead is use this command. So git add is the one we already know, right? I'm going to do the file, so it's called math.py, I believe. And I'm going to add a flag called -p, which stands for, I forgot what it stands for. I think it stands for patch, but you can look that up. I think Juan, if he's in the chat, he knows what it stands for. But essentially what this lets you do is chunk up changes into little sections. So before I click on, or before I enter git add, if I look at the difference viewer, you can see that these two green sections are now separated, right? Obviously they're two different changes, they're two different chunks or hunks of code. And when I enter this command, it'll essentially go through each section of code and ask me, hey, do you want to commit this part? Yeah, okay, cool. No, okay, next one. And I'll go through each kind of green section and ask me if I want to add it or not, right? So let's go ahead and add a couple more changes maybe to make this even more obvious. Let's add another function here maybe called toScalar, and it just converts a vector to a scalar, right? Something perfect. I don't know. Sure, that works fine. And let's do another one called norm, which returns the norm of a vector. I don't know. I'm just making these up as I go along. The actual functions again don't matter. So yeah. So now if I look at this, you can see I have 3 green chunks of code, or hunks of code as they're called. I have this hunk, and this hunk. So when I enter this command now into the command line with the -p flag, it'll give me 3 prompts. So if I enter this right now, I'm gonna, okay, maybe not, it didn't work the way I wanted it to. It worked in the example I did earlier when I tested this, but it didn't work this time. I don't know why. But so there's only one hunk here, so I don't know why it detected all this as one big change. Maybe it's the way I did it, I don't know. So I'm gonna quickly exit out of this. There we go. I want to undo some of the changes I did. So I'm just gonna go back to my normal example that I did before. Cool. So this example right here, where I just have these 3 functions and I just changed this into -1, this into 0. If I run that command again, okay, now it's giving me 2 hunks. I don't know. It's a bit weird. Gets a bit weird sometimes with how it detects diffs and stuff. I don't know what it is, but as you can see here, I have 1 of 2 hunks. I don't know why they're called hunks, by the way. That's probably some historical reason. I personally would probably just call them chunks of code because calling them hunks of code sounds weird. But anyway, as you can see, I have 1 of 2 things. It shows you the first difference right here. The first thing, I guess, the first chunk of code is this one right here. And it's telling me that this line got removed, which is why there's a minus there, and this line got added. And it's asking me if I want to stage this hunk, and then there's a bunch of options. Yes, no, and then all of these options. Essentially, Nosher's the biggest hunk. Thanks, Torin. Basically, this is yes, and this is no, obviously. And then these all are like very weird. So some of these mean like skip this hunk but go to the next one and come back to this one later. Some of these mean say yes for now but then come back to it at the end. Some of these mean say no but come back to it. Like, it's really weird. You can Google these. There's like so many of them, and most of them are useless. 99% of the time you're only going to use yes or no, right? So obviously, like, I'm just going to use that. So in my example right now, I'm going to basically in my code, I'm going to push this change first, or commit this change first, and then I'm going to commit this change first. So first is wedge product and then cross product, okay? So in this example, wedge product, yeah, I want to commit this hunk, right? So I'll click yes. And then I'll ask me about the second one. It gives you a bunch of information too about line numbers here as well, from to and from. So this is the second section. This is the dot product. I do not want to commit this hunk of code, so I'm just going to type in no, press enter. And then that's the add done. If I do git status, it'll say that I modified this file, but there's also changes. And this is the second function that I didn't end up committing. And then what I can do now is I can just do the normal stuff where I do git, commit -m. And I can do update, wedge product function or something. Cool. We have 1 file change, 1 insertion, 1 deletion, which is perfect. I deleted 1 line and inserted 1 line technically. So yeah. And then if I do git push, and I go back to the remote repository over here, go to this new file, you can see that the last commit date is now. If I go here, you can see this returns -1, but this is still the old shitty function that we have to edit. So now I go back here. I can, at this point, there's only one diff, like one thing left, or one hunk left. So I could just do git add and the name of the file without the -p, and it would work just the same. But just for completeness, I'm just gonna do this again. And then as you can see, there's the last hunk, 1 out of 1. It's asking me if I want to stage it. I'll type in yes. And then if I do git status again, you can see that's the last change that we ever have on this repository. And then I can just do update. What is this? Cross products function, like that. And then do git push right after that. Boom. If I go back here, refresh, there it is. And if I look at the history, as you can see now, instead of having like one commit that just says update math.py with new functions or something or whatever it is, I have this, which is a bit easier to like go through. And again, you wouldn't do this for literally 1 line, but for like a file with like thousands of lines of code with like tens of files as well, this might be a really useful way to organize code. In other like places as well, like inside of VS Code, what I'll do oftentimes is I won't use the -p flag that way. I'll do it interactively through here. So if I add like a bunch of code, let's just do write a function to that. I don't know why I didn't complete the function. It's giving me return 0. We're gonna quickly get it to it's not giving me. Okay, let's just quickly do this. My star cells result equals 0. Let's see if it auto completes it for. Wow, it's really bad at calculating functions properly, I guess. But I'm just gonna make a bunch of functions real quick that are slightly longer, hopefully. There we go. And then let's just do like one more. Cool. Maybe one more. Cool. So we have a bunch of these new functions now. It doesn't matter what they do. But if I look inside of GitHub or inside of VS Code, if I click on the diff viewer, the difference viewer here, you can see this is one big green blob. And if I were to do like the git add p thing, it would probably, I'd consider this as one big hunk of code. What I like to do oftentimes is select it manually this way, and right click on it, and then click on stage selected ranges right here. I think you can do that through the terminal too. I don't trust it, because if it's this much code I'm working with that I want to see visually, I'd rather just look at it myself. So if I do stage selected ranges, and it's staged now, so now I can go back here, do git commit this, add, what was it? I added the determinate function, git push, and then I can go ahead and look back over here at the history. And I should have, added determinate function and only added this function right here. And then I could maybe add like these two in chunks and this one in chunk. Point is, this feature, I guess, allows you to, instead of adding a huge file, chop it up into smaller things and then commit those separately. And yeah, the second thing, which I'm not sure if you covered last time, but it's kind of nice to know, is git reset. Git reset's a very iffy command to work with. A lot of people are scared of it as well. So I'm just going to quickly copy some of these changes in my clipboard. So let's say I just want to nuke everything. I added a bunch of code here, and I just do not want to, like, I don't want to deal with it. I don't know what to do. I want to restart. A useful command to know is git reset hard. This is a very, very strong command though. Like be careful when you use this, because this will nuke all your changes that you have currently that you have not committed. So if I haven't committed to push anything, it'll nuke everything. So if I just do this right now, it'll tell you which commit it's pointing to most recently. So if you remember our last commit, so I'm sorry, I don't know how to answer that, to be honest, but maybe if you use git reset, that might help. I'm not sure though. Anyway, over here you can see that this is the most recent commit it's pointing to. If I go through the history of the tree, the working tree as well, you can see that the most recent thing on the head is right there. And if I do git status now, no changes, absolutely nuked. Even here you can see the things I copied over here, completely deleted. I can also do, there we go. These are the chances to have them copied in my clipboard. Another thing you can do as well is git reset soft, and then I think it's head this. So what this does is, let me just double check the command before because reset is a complicated one. Even I get confused about it sometimes. Yeah, okay. So what you can do as well is, so what this will do is so head is like the topmost commit. When you add this head argument with a tilde and then a number, it'll basically go that many commits backwards and set your repo to, or your local repository to that set of changes. So if I go back to git status, if I look at the VS Code diff viewer, it should hopefully, incoming, outgoing. It is a bit complicated, but it'll show you like the most recent changes from that commit that were committed, and you can have the choice to like redo them or not redo them, whatever. The difference between soft and hard here would be that soft keeps the changes that you had as well and then adds on the changes from this commit, and hard would nuke your changes and then add these changes basically. So if I were to do if I just do git reset hard real quick to go back to normal, and then do this, and then change this to hard. So right now I'm back at wedge product function. Right, if I do this, it'll initial commit. So hard will nuke the changes from where you are right now and then go back 2 steps. In this case, I added 2. If I did I can't go any further back because I'm at the first commit ever. But if I were to do 5, it'll give me 5 back, blah blah blah, whatever. Also this repo is really messed up right now locally, the local repo. So I'm just going back to this. Second. So if I'm currently at initial commit now on this local repository. So if I want to go back to the most current up-to-date version, I'll just pull it again, and that works. As you can see, one file change, 18 insertions. If I go back to VS Code right here, this file is back to normal. So yeah, git reset's a bit complicated. There's hard and soft resets. If I were to read off the definition of it, the key difference between these is that a soft reset does not revert the staged or working tree. So again, if you have changes that you staged, and then you do a soft reset somewhere else, to somewhere else, it'll still keep your changes on that were committed or that were staged. But if you do a hard reset, it'll nuke your changes that were staged and then go to wherever you want to go. So yeah, that's the difference. It's like kind of in the name, I guess. Soft is like a nice reset. Hard is like a really aggressive reset. But yeah, that's the two, I guess, quote unquote complicated commands we want to go through. Next up is the project management stuff, which is kind of more fun to look at. It's not just code, so that'll be cool. So there are a few three tools we want to talk about that GitHub provides. So I'm gonna close this now because we don't need it. Or I guess go over here. So the first thing I'll talk about is workflows, or actions as they're called on GitHub, which is automated for workflows. So essentially, what GitHub lets you do is have these actions which are controlled with a .yml file or a YAML file, and they let you automate certain processes on your repository. So let's say I had this won't work for this repository because there's not enough code or any configuration setup, but let's just say, oh, 1 second. Okay, cool. So let's just say that I had like a linter, which is something that like makes your code look nice, like it formats it or whatever. It's technically not that, but let's just assume that. Or like let's say I wanted to have a thing that I write a bunch of test files in Python that test my code, and then I want GitHub to actually make sure that those tests all passed, right? Or let's say I built a React app and I want GitHub to make sure that every time something gets pushed to main, that the code that gets pushed is actually, it can actually compile like to a React app and doesn't just crash. Like all those things can be done through GitHub. So when you have a blank repo with nothing on it, like Git 102 for example, you click on the Actions tab right here, and then it asks you like, oh look, these are some of the suggested things. It'll read the language that your repository is in mainly, and then it'll recommend you things from there. So for example, PyLint is a very common linter for Python. And again, a linter is something that formats your code to a specific standard so it looks the same. It's very useful in a big team of people where everyone might have different ways of coding or different styles of coding. Some people might use semicolons, some people might not. Some people might use like something else. People might use like 2 tabs or 2 spaces for a tab. Some people might use 4. A linter is a way to like kind of standardize that and make sure that everything in your code is just one way. So that's where linter can come in, and that's where GitHub Actions automation comes in too. So if I were to configure this won't work for this repository, but when you do configure an action, it is all these parameters that it asks you for. Most of these are kind of not important, actually. Most of these are set up pretty well where you don't have to do much. The name you can call whatever you want here, as long as it doesn't have any special characters in it. Basically, this action will get triggered depending on something happening. So in this case, it'll get triggered on a push. That's what it's saying. So every time there is a push on this branch, it'll trigger this entire job. Basically, is what it's saying. And then the job or the jobs, I guess every action consists of specific jobs that happen. So again, this is a very like DevOps or developer operations oriented stuff. So if you want to read more in depth about how to like set up pipelines and workflows and all that stuff, it's a whole like field. But we're gonna go to the very basics here. Essentially, this is like a way to describe like how when it does what it does, it needs to like kind of set up a virtual machine and then do a bunch of fancy stuff. Blah 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 blah. None of that's really important for you. Oh, thanks for the follow. But essentially, none of that's really important for you. You don't need to know any of this because when you set up a workflow, like you can literally just click commit change right now and it'll work fine, probably, as long as you have a pilot configuration file in your project. This will work fine. But essentially, this is like a set of jobs that happen every time a push happens on your thing, and you can write your own workflows too. Like you can literally just write, go to this folder .github workflows in your repository, and like so if I were to like commit this, for example, directly to the branch. So if I committed this directly to this branch, now if I were to go to my local repository and pull, there's a change there, and if I go back to my VS Code, you can see I have this GitHub folder and it has this pilot YAML file. So it's literally that easy that you could make another YAML file in here. I could call it like, pilot 2 or something, just to like that, and pilot times 2. I don't know why you do this, but let's just say like you can write your own. Let's say you write your own like very customized workflow, whatever, and then you were to just add it and commit it, add another weird workflow, and then push that. And then go back here. You can see now I'll have two workflows in here, which is Pylon and Pylon 2. I don't know why I call it that. And if I go to the Actions tab, you can see I have Pylon and Pylon X2. And yeah, you can track essentially every time I push code to this repository, this entire workflow will be triggered. You can like monitor it and stuff. You can look at what failed. As you can see, this failed really badly because there's actually no Pylon installed in this project. I'll show an example of where this actually works really well. Um, in our hotcacks repository for the landing page, for some reason this used to be set up like months ago and then got deleted. I set it up again like today, but it was set up a long time ago. But essentially, we have this linter called ESLint, which makes our JavaScript code look really pretty, essentially, and also catch errors. And every time someone pushes code to this main branch, that commit will have this little check mark sign or an X sign or a circle, which means it's still working. And you can click in here. It says, the job was ESLint run ESLint scanning. So again, in this case, again, ESLint is just a linter that we're using for our project. And it says it's successful and it took 36 seconds. You can look at the logs if you really want to. These are all the jobs that happened. So setting up the jobs themselves, and these are all the actual jobs that happened one by one. And there's also instances of where this fails. I don't know if we have any of those to show off here. If I go here, yeah, all of these should have passed. So sometimes these will fail because let's just say someone pushed code that wasn't formatted correctly because I don't know, they didn't install ESLint on their VS Code and they pushed code that looks like absolute dog shit. This will just fail. It'll still push the changes or whatever, but it'll just let you know, hey, you fucked up. And in this case, it's nothing crazy. It's just, oh yeah, my linter wasn't signed properly. But this can also prevent like you accidentally deploying. Like let's say you have a GitHub action that deploys, compiles and deploys your website to a server. And then if it fails, it won't just compile. It won't just push this broken website to your thing. It'll just stop itself, right? Because let's say it compiles your React app, for example, and your React app is actually not working. Instead of like it actually pushing that code to the server and letting it run and then letting people go onto the website and not be able to access your website properly, it'll just stop the job. So yeah, that's a cool feature about GitHub Actions, I guess. And again, there's a lot. I only showed off like one. If I do new workflow here, there's so many. There's like literally hundreds and hundreds and hundreds of workflows, and then you can go online and find people who like make them too. They're sorted by like deployment, security, CI, automation pages. There's a lot of stuff. So make sure you like explore that because it's really cool. But yeah, the next product we'll be talking about is Wiki, which is a very simple product actually. I'll show an example of what it looks like first, and then I'll show how to set it up. So this is a project I worked on personally a few years ago. Called MuseSpace. It's a social media app. And this is for a software engineering class, so we needed to write a wiki or a set of documentation. So we decided to use GitHub Wiki for this, which again, this is a great use case. If you're in software engineering, the class, and like your prof is actually kind of chill, and they let you do whatever you want, and they require a bunch of documentation, this is the perfect place to do it. So as you can see, these are all the pages in our Wikipedia or our wiki, and you can see we kind of like went over basically every single thing that you could with this product. You have different sections. Basically every like feature of our website has a page here, and it documents like a bunch of things about what everything is, what stuff looks like, and it's really like obviously this looks fancy or whatever. But if I were to edit any of these documents, you can see this is just Markdown, which is just like a ghetto HTML, I guess you could say. Or I guess in here we actually use HTML, so you can use either HTML or you can use Markdown. They both work fine. And in this case, we use HTML. I don't know why. Markdown is probably just better. But you can see this is really easy to lay out. If I go back to like another page, like the sidebar, for example, this is kind of a bigger one, I guess. If I go to edit page, you can just see it's literally just very basic HTML. The nice thing is that GitHub will automatically format your HTML to look nice with CSS that they run themselves. Because as you can see, these are all just H1, H2, A. Like it's very basic HTML. There's nothing here. There's no styling at all, but it doesn't look like absolute shit here. And that's because GitHub has their own like styling that they do on the back. But yeah, it's also really easy to nest stuff. If I do a new page, I'm not gonna do it here. Actually, I'm gonna show off how to do it on the test repo. But yeah, it's a really cool way of like showing users how to use your website or whatever it is. If I go to Git 102 and I click on the Wiki tab, As you can see, don't have a wiki for this yet. Why would I? Create the first page, call it home. Welcome to the Git 102 wiki. And then there's also a commit message you can add here too. Save page. And as you can see, this is the first page of our wiki. You can also add a custom sidebar, which is cool. If you really wanted to, you could code a sidebar. So you can like filter what shows up in the sidebar, what doesn't. If you don't want every single header, like H1, H2, H3, H4, H5 to show up in the sidebar, you could format it as such. And as you can see, there's a lot more options than just HTML and Markdown, apparently. Wow. There's ASCII doc, all these things. So if you know any of those, there you go. But as you can see here, I have the home page. I can add a new page. I can call it math functions. And I can just write a very basic. I'm going to use Markdown because it's easier to type out than HTML. Math functions. This is a wiki to document all the different types of math functions in my project. And then I can list them off one by one. I can do like wedge, cross product, and talk about that here. Then I can do dot product, not dog, dot product. Talk about that here, and then wedge product, and talk about that here. Cool. That's cool. I can just be like start work on the math functions page. And this is also kind of treated like a repository. That's why there's like this edit. It's called an edit message, but it's really a commit message. Everything on Git is a Git repo. Even if they try to act like it, then it's not. Saving a page is the exact same thing as committing. If I go here, as you can see now, I have this home page from before, and I have this math functions, which is divided into all these things. I can click on each one and go to it directly if I really wanted to. And I can like really nest this stuff really deeply, I think. I don't know how far it goes, but I could like nest this like 5, 6. This is a H6. I'm just gonna type H6 here. Save. Yeah, it goes really deep. So if you want to nest stuff like really advanced, you could. And then if you add a custom sidebar, you can show off. You could like basically code a way so that it only shows certain header tags, or you have your own custom setup, navigation, whatever it is. But it's really cool. And then if I click on wiki now, this is what it looks like from the get-go. So yeah, it's a cool little, I guess, feature that Git adds or GitHub has. There's some really cool repos I could probably show off real quick. If I do like, I don't even know what the Linux one's called. What's that? GitHub Linux. Oh man, I need like a famous. Let's do GitHub React. Let's do. I'm sure React has a wiki. If they didn't, that'd be so sad. Oh shit. Well, they did at one point apparently. So let me see if I can find one more. We'll go with it. Otherwise, we'll call it quits. Let's GitHub. Ah man, everyone moved their wiki off of GitHub Wiki, but it is a cool, easy way to write a wiki without having to make a whole website for it. As you can see, this is what this wiki is for this website or for this product. But this used to look very similar to. This is basically a carbon copy of what it would have looked like on GitHub. It's the exact same, and it's written the exact same way too. The source code, if you were to look at it, would just be Markdown, pretty simple Markdown. So yeah, that's that. And the very last thing we'll be talking about today, other than wikis, is projects, which is a very big product. It has a lot of features. I'm going to talk about most of them, but we're going to show off some examples and then show off how to do it on our Git repo. Or a Git 102 repo. Sorry. Oh, you can see right here, by the way, it failed. There you go. Just in case you were wondering, that workflow from earlier failed. Anyway, cool. So what we're going to talk about is projects. So the first thing I'm going to cover is issues, which is a part of projects. It used to not be a part of projects. Now it is. So kind of weird. But issues on a repository is a way to track issues. It's pretty obvious. For example, I'm showing an example off here of Hawkhacks again because it has a lot of issues. But basically, as you can see here, these were all made by somebody documenting different things that we need to either work on or address, or there's like some sort of glitch or there's some sort of feature. As you can see, all these have tags as well. So when you do make a new issue, for example, so let's say I make a new issue and I call it, I'm just going to call it test feature for now. Add a way for the user to use keybinds to open our socials. I don't know, some really weird thing, right? This is like, I'll say, an issue that I want someone to work on. I could also do something like test bug or test. I don't know what the formatting is for our issues, but it could be something like let's just do when the website loads, the hero banner fades out. I don't know, some random error. I can assign it to somebody. I can assign up to 10 people, so I can click on a bunch of people. I'm just gonna give all these people notifications for no reason right now. We'll do me. We'll do Juan. All right, cool. Click that. Boom. Assign it to all those people. I can give it a label too. So in this case, it's a bug. But there's also stuff like documentation, duplicate, enhancement, and you can make your own labels too for your own projects. I'll show you how to do that later. You can you can mark this as a good first issue. So if you have like people constantly being added to your team and you want them to work on something very simple, like as their first ticket to get familiar with how the code works, you can mark issues as good first issues for that. And then there's a bunch of other stuff here too that you can do. As you can see right now, there's also a project section. We don't have a project yet. Oh, we do, but like I'm not gonna use that because we're gonna make our own project on Git 102. And then you can set a milestone, which this is pretty complicated. Not gonna explain how that works. And yeah, this is a test issue. Please ignore. And I could also attach an image here if I really wanted to. Most of the time, it's nice if you do find something on a website that's not working properly to show like an image or a video of why it's not working. It's pretty easy to upload those. I think it's somewhere here. I'm just being really stupid, but there's a way to embed images in here. Oh, right there. Paste, drop, or click to add files. So you can add a little image there. But yeah, I'm going to make this issue. All these people are going to get notifications just now, and they're probably going to maybe panic, some of them, that, oh shit, not sure. Made a GitHub thing, and I got assigned to it. What the fuck? And then you can also make a branch from here directly too, related to this issue. So instead of, let's just say in your project, every new feature or error or bug or whatever has an associated branch with it, instead of making that branch and then somehow trying to link the issue with the branch, you can just click on this button right here, give it a name. Obviously not something that long, but you can do something like bug, hero fading out. And then you can make sure this is set right. All this stuff, and yeah, you can make a branch through there too. Really cool way to like kind of, I guess, track issues on GitHub and assign, kind of see who's doing what basically. But this is like pretty self-explanatory, pretty basic. Like it's not that comprehensive or anything. The cool stuff is when you go to the project section. Oh yeah, this is the hotkeys. It doesn't have a project section. A project I could show off actually. That I talked about, which I had open, but I think I closed it by accident, is Laurier CS projects. I think that's the URL. No? Let's see if I click this and then click on projects. Cool. So these are projects. So every org or user has a set of projects under their account. In this case, we have a bunch for our pods. So I have permission to show off the pod 1, so we're chilling. But essentially, this is what a project looks like. It's actually really cool. It's a Kanban board, if you know what that is. And you can see these are all actual issues. So if I were to go back to, I don't know what the repository is called for this project. I forgot. But if I were to find the repo for this project and then look at the issues tab, a lot of these these things right here would actually just be issues that have been turned into like, would have been converted onto this project. So let's say working on Gmail API. Let's click on this, for example. We can see here, good job using issue descriptions really well with the little checkbox stuff. I love that. But basically, as you can see here, in our issue that we made on Hotcaks, I left the project section empty. But here you can link it to this project, for example, so pod 1 project. And you can see a bunch of status updates. You can see the status here, and you can like set it to different things. So let's just say you have a bunch of issues you want people to work on, but maybe not yet. Maybe you want to just throw them in there, and then you want people to work on them later. You can throw them in the backlog section. This is very basic, like Kanban stuff. I guess these 5 tags. To do is stuff that you want people to do. In progress is stuff that's being worked on. In review is stuff that's been finished. Needs people to be looked at. Might need some edits or maybe some constructive criticism or whatever. And then once everything's been done, you can just move it to done. And the nice thing is you can just drag these around. You can literally just like drag these up and down. You don't have to like click in here and then set the status for blah blah blah. It's really cool. So for example, this ticket right now I could assign. Oh, it's already assigned to somebody. But I could drag this into to do. I'm not going to because it's someone's project. And then this person would get a notification saying, hey, Nosh should move this ticket from this to do. You should start working on it, whatever. And then it's a cool way to track. You can also see other stuff here like roadmaps. So you can see how like it's kind of like a timeline to see a breakdown of like how when tickets get completed and how. There's also more complicated features which aren't in this project, but I'll show them off just now. So if I go back to my Git 102 project, which does not have a repo, sorry, and click on projects, create new project, click on the new project button. I don't know why it's like that. Anyway, so there's some like templates which are really nice. I'm just gonna use the team planning template. There's a lot of stuff in here that we're not gonna look at though. It's really fucking complicated. You can make a blank project with nothing in it and make all those views one by one as well if you really want to, if you're really crazy. But I'm not doing that. I don't have time for that. We're gonna call this Git 102 project. So as you can see here, we have a very simplified Kanban board compared to the one we had on LCS. We can still do the same thing though, where we can make tickets and assign those. So if I were to go to the repo, back to the repo, if I let's go back a bunch, go to issues. So I made this issue a while back, like I got an hour ago, just for a test. What I can do is assign this to a project now. So I can assign this to Git 102 project, and now it's being tracked by this project. I can also set the status to do, because I haven't worked on it yet, so it's gonna be in to do. If I go to projects now, you can see that on this Kanban board it's been updated. And if I were to drag this here to in progress, let's say I start working on it, I'll get a notification saying, oh yeah, it's gonna move to here to here. So if I do that, boom, click on this, please, there we go. And you can see the status here changed. There's a bunch of things here too. There's a bunch of features here that are very software engineering oriented, but we'll go into some of them and not all of them because you'll learn those later. It's like very agile workflow stuff. So as you can see here, there's like a bunch of stuff here. There's like estimate 0. You like what does that mean? If you go here, there's priority, size, estimate, iteration, starting. Like what is all of this stuff, right? So basically, when you're working on teams, most of the time your teams are agile, which is like a way of working. That's essentially what it is. A methodology. It's a way of working. And essentially in this methodology, you have these periods of time called sprints. That could be, it's usually a 2-week period. I think standard it's 2-week period, but it could be like a week, it could be a month, whatever your team works best with. But it's usually 2 weeks to a week. And all in this example on GitHub, iteration is kind of the sprint you're on. So I don't know why GitHub calls it iteration. I think that's like the more fancy business term, but it's basically sprint. As you can see here, it's a 2-week period. I think 26 plus 14 is March 10th. Yeah, it is. Yeah. So as you can see here, they have like 3 sprints set up for like the current sprint that we're on, which I guess would start today and go to March 10th, which is 2 weeks away from now. And then March 11th to March 24th, and then March 25th to April 7th. So that's sprint 1, sprint 2, sprint 3. So I can assign this to sprint 1, for example. And now I can see this ticket is a part of the current sprint. So ideally, it should be done when this sprint's done. And that's kind of, very logical. Estimate is kind of like a number to signify how complicated or how much work is required. It's not how complicated, it's how much work is required to complete this ticket. Very different from how complicated something is. Something can be very complicated but not require a lot of work. And then on the flip side, something could be really simple but really take a long time to complete. So this estimate is kind of like a number to designate how big of a ticket this is. By standard, I think the lowest number is easy, and then the bigger the number, the more complicated it is, if I remember correctly. And there's a lot of different like specifications and how these numbers should be decided. It's very arbitrary. There's no like global rule. Like 10 doesn't mean 10 everywhere. It's very team dependent, company dependent, project dependent. A 10 for my project that I'm working on, maybe the new space one, could be ranked 3 in a different project, which is like a lot bigger, maybe, for example, right? So it really depends on everything. It's very arbitrary. People tend to use the Fibonacci numbers for this. So 1, 1, 2, 3, 5, 8, 11, 26. I forgot. I think that's right. I'm not sure. But in this case, code doesn't work on Mac OS. That's a pretty big deal. It's probably gonna take me a long time to work on. So I'm gonna set it like to 10, maybe. Because I feel like 10, it just feels right to give it an estimate of 10. Size, this is a pretty big ticket. Actually, it might not be a really big ticket. It might be a kind of big ticket. It's like okay, because it is a big issue, but the code might not actually be that complicated to fix this. And then priority, P0 is priority 0, which means like this needs to be completed yesterday, and then P1, P2. As you go down, it's like, oh, this ticket needs to be completed tomorrow. Oh, this ticket needs to be completed like in a week. Blah blah blah. So priority obviously pretty self-explanatory too. And this is a big deal for me. I want my math functions to work on Mac OS like straight away. So I'm gonna make this a P0 ticket or PO ticket. And then if I close this now, you can see that this ticket has a bunch of new information on it. You can see what iteration it's on or what sprint. You can see it's a medium ticket, estimate 10, and it's a P0 ticket. That's why it's in deep red. I can make a new item too. So if I add item, so if I select the repository, so Git 102, and then create new issue. So let's create a new issue. Let's do let's just say like code doesn't work on Ubuntu, for example. This is another issue I thought of, right? Create that. Test description. And over here, I can already label this as stuff here too. So I'm gonna call this a bug. This project, this milestone. I'm gonna assign it to myself. Actually, I'm not gonna assign it to anybody. Sorry, we'll leave it like that. Create. As you can see here, this new ticket or issue is created. These are also called tickets, I guess, too. So if I use ticket and issue interchangeably, that's why. I don't really give a shit about Ubuntu, so this is not a big priority. I don't give a shit. So I'm gonna call it P2 because who cares? Who uses Ubuntu anyway, right? Again, probably not gonna be a big ticket. Probably gonna be a medium-sized ticket. I don't think it'll be that thing. 10 for that as well. I don't want this to be done current sprint. I want it to be done for the next sprint or even the one after that. So let's do I3, and then boom. We set all that to there, and as you can see, it got added to our Kanban board right here. And this is the instance where I would make like a backlog and put this into the backlog because I actually don't want to see it in my to-do, because to-do implies it needs to be completed at some point soon. Backlog is like, we'll figure it out someday, right? And I don't really care about Ubuntu, so yeah. And then you can obviously filter by iteration. So if I filter by iteration current, which is the current sprint, you can only see the tickets that would be worked on for this sprint, and you can see the other one disappeared. If I get rid of this filter and I go here, and then you can see the iteration 3 tickets. There's the only one. Just to complete this, I'll make one more issue. Will be like, I don't know. Function returns the wrong value. Let's do the wedge product function. This is again in reference to the code I wrote earlier. Label bug. I'll probably actually let's do a different one. Let's do enhancement. Wedge function should return float instead of int, for example. Let's do that. Same stuff. Not assigned to anybody. I'm gonna label it as an enhancement. Create. This is something that isn't a big deal, so I'm gonna give it a priority of P2 again. A very small, like very extra small ticket actually. It's as simple as converting one number somewhere. So I'm gonna give it like a 2, not even. Iteration, probably like the next one. I don't really care right now. I'm currently worrying about stuff right now, not this like really small thing. So yeah, go back here. You can see got added to the list of stuff to do. If I click on iteration 3, you can see this is the iteration 3 tickets. And yeah, that's a very brief way of looking at GitHub projects. You can also see a bunch of other stuff here too, which we didn't talk about, like a roadmap, which shows you a timeline of like your tickets essentially. There's current iteration, so you can see all this stuff. Again, this is an easier way of looking at like what I did earlier, which is this. Easier way of doing that, I guess. And then team capacity. This is like essentially estimating how much. So these numbers, these estimate numbers, these are important because the bigger your number is, the more stuff you have to do, and you have like a certain number that you can manage without stressing too much. And if you go over that number, you'll start to really get overloaded with work. So this is a really important way to like manage people's mental, I guess, and make sure that people aren't doing too much. And this is very like, again, you're most likely not going to use this specific feature in your personal projects, but if you're working at a company, this is a very big deal. Oftentimes you'll have like sprint reflections or introspections or whatever, and you look at the sprint and you'll be like, okay, maybe this person was doing way too much. They were like an estimate of 10, but they were doing 30. So maybe we should lower their plate to 20 this sprint and 10 next sprint, and like slowly get them back. And maybe this person can like, they're at 10 right now, but they're like really blasting through it. So we could probably add some stuff to their plate. Like that's kind of what the estimate's for. And yeah, again, this is very complicated. There's a lot more stuff here, but I'm not going to go through that. Like this like way to look at insights as well. showing like static, like different charts. You can make charts as well. You can show like different people and how they're performing or whatever it is. So yeah, that's basically everything for GitHub projects. That's basically everything that we wanted to cover in the slideshow today, actually, too. And yeah, does anyone have any, I guess, questions about any of that? There's a lot of content, and this will be on YouTube, so don't worry too much. But yeah, I'll give it a couple minutes, and then otherwise I'll call it. And obviously, this code, I don't know, it's not useful, but it's on our repo, it's on GitHub on our org under github.com/lauriercs/git102. So if you are interested for some reason, feel free to look at their code on the projects and stuff. But yeah, I'll give it like a minute and then call it. Cool. All right. Well, hopefully it was enjoyable, somewhat maybe useful. Hopefully, there's some very complicated project management stuff there, but yeah, it's really useful. Maybe you want to implement some of it in your personal projects. Not all of it, but maybe the issues is nice. GitHub issues are a really easy thing to use, in my opinion, without using the project section. And it allows you to like track tickets pretty easy rather than like maybe using like a Google Doc or a Notion page. You can just directly do it in the code, and then it'll like show you stuff in your VS Code related to that as well, which is really nice. And maybe later on you want to use like projects to, you have a big team of people now that are working on this project, and you want to use GitHub projects to track everybody's changes and all that stuff. So yeah, cool. No worries, Torin. All right, well, I guess we're calling it there. Thanks for coming, and yeah, see y'all next time. Bye.